Okay, dear student, let's see how to do this question. Light of wavelength 5.8 10 to the power negative 7 meter is normally incident on a diffraction grating that has 400,000 lines in 1 meter. How many maxima can be observed with this diffraction grating? Point number one that I would like to make here for this question is this is a very popular question with IB. And this is not the first time that I'm asking this question. This has been asked so many times over last 30, 40 years, I would say. They have consistently asked the same question again and again, which clearly means that students are facing problem in these kind of questions repeatedly. Today, let us seize that. And you will not be finding problem later on in this kind of question. Let's see. So what we do, like point number one that you have to remember is like in the case of diffraction grating, the name is diffraction, but the only formula that you use is interference formula. Sine theta is equal to n lambda by d, not b. If it was b, it will be diffraction formula. It is d, it's similar to interference formula. This is what we are going to use in this question. Now, sine theta value has to be lesser than or equal to 1, always, that we know from mathematical point of view, because sine theta is like it is always having values ranged between 1 and -1. So you know it in maths, isn't it? So sine theta is less than equal to 1. Now let us plug in the values and find the value of n. So n wavelength is 5.8 10 raised to the power negative 7. And d value, how are you going to find the value of d? It is not given directly, but they have given that there are 400,000 lines in 1 meter. So d value will be obviously 1 meter divided by the total number of slits, that is 400,000. That becomes the d, and the unit is still meters, so there is no multiplicative factor there. So we just plug in this value here. It will be 400,000 like this. This value has to be less than equal to 1. We want to comment on the value of n. So n, now this fraction, like we are just going to create a reciprocal there. So it will become 5.8 10 raised to power negative 7 into 4 into 10 raised to power 5 less than equal to 1. Yeah, like this. And we have to find the value here. So this value gets cancelled out, and you are still having 100 in the denominator. But what is 4 multiplied by 5.8? So 4 multiplied by 5.8 will be 23.2. So n value can be written as lesser than 100 divided by 23.2. So which gives you the value of 4.3. 4.3. It means n is an integer which is having value lesser than 4.3. It means that n value will be equal to 4. It cannot be anything else, no? N value is equal to 4. Now, another catch in this question is people will directly jump to the option and they will say, oh yeah, A, there is 4 written there, and you would be ticking it. And you will say that, yeah, A is the correct answer. But beware, this is the another point where students are always making mistake. 4 is not the right answer. The question is about how many maximas can be observed with this diffraction grating. 4 is the maxima only on one side. What is happening? Like, do you remember the other question when there was so many lines there? So you would be getting those kind of that kind of a pattern here. Like this is central maxima, then 1, 2, 3, 4, like this, and then here 1, 2, 3, and 4. So overall, 4 here, 4 here, 8 and 1 here, 9. So total 9 will be your answer. How many maximas can be observed? Because at this point there will be the first diffraction minima, and here it will be the first diffraction minima. So we are only concerned with this much of the area, and including the positive and the below one, there will be 4 up, 4 below, 8, and 1 will be the central maxima because it is counted as 0. So total there are 9 fringes which will be visible. So this will be your correct answer. And this is a repeat telecast question, so no worries, no wonder if the question comes back again. So be very careful about this question. Let us verify the answer for this question. Well, yeah, I know the answer is D, so no problem. We can take that. Okay, dear students, thanks for watching the video. All the best.